Optical reflection is a tool that creates physically based reflections. Essentially, it works by shooting a ray from the camera to the object and then uses the normal path to calculate a reflection vector that then samples from an infinitely large square with an HDRI on it to get the color. Let me walk you through it. So it has 3 inputs. It has a camera input, of course, an HDRI input, and then it has the world normal path there. So what USET does is the image that you get. I'll walk you through the outputs. Here is the reflection, is what you're seeing, of course. You got a Fresnel map. This is not just a phasing ratio. This is a properly calculated Fresnel map using the Fresnel equations. So if I change the material properties, this will change with it in a physically accurate way. And of course, this is also used internally. So we got ST map. This is just what is being sampled from the ST map. And then the reflection vectors. This might be useful, for example, if I just put an IP mat underneath there to make selections inside reflection. So if you have a render with a specular highlight that you want to select, when you want to isolate, you can use this to make selections like that in a reflection, and this selection will move if I actually select it. This will actually move with it like a reflection. So that's what that is. But usually you want to set this reflection, give it a reflection. Then we got a rotate function. This is just rotating that infinite sphere around. So you can see if I put this here, you can see that that's rotating the sphere like that. That's pretty obvious. Then there's different reflection types. You got the naive reflection. This is just, there's no Fresneling at all. This is just 100% pure reflection. Then you got the dielectric materials. This is most things, cloth, ice, glass, what have you. And then you got metallic materials, which has a extinction coefficient for metallic materials, obviously. And then you got a bunch of presets, so you can set it to water, corneas, which is what I used for a lot, and then metallic properties like mercury, copper, gold, stuff like that. So let's set this to water right now. Then you got diffuse here. This is just to create a diffuse map underneath, which can be useful for certain if you're trying to match a material in your plate, for example. That's what this is. And you can get an albedo map as well if you have a texture. That's what that is for. And then roughness, very useful to get some roughness in the image. So it's not a pure, perfect specular reflection. This is the only function in the tool that is not 100%, doesn't conserve energy properly 100%, and that's just to maintain speed. If this was accurate, it would take a very long time to render, which is not necessarily what you want. Let's set this to copper so you can actually see this a little bit better. Copper. Set the roughness to say 0.5. And then here I have a roughness pass, which is just a p pass. I'm running through the position, which I can select here, the roughness pass. That's the roughness pass. And this will multiply the roughness with that map, so you create some nice gradation in your roughness, so it's not the full object, which is nice to have. And then here the steps just creates how precise that is. I'm gonna just turn this off for now, and then we got thin film interference, which is probably not useful in production, but is a lot of fun. So if I turn this on, you'll see it's a thin layer of oil that creates all these kind of funky interference patterns. And the way this works is you have a incident material here. This is normally air, which is of course set here. By the way, incident material is usually set to 1. The only difference would be if you're underwater, you set this to 1.33. The incident material is just the refractive index of the air itself. But if you have an incident ray coming in, it hits a thin film of a material, and then part of that light reflects, part of that refracts through that thin film material and then bounces off the main material and then refracts back through the thin film. And in reality, those two rays will be very, very close together. And those two waves then interfere with each other, creating these different patterns. That's basically how this works. You can see that here with a soap bubble. There's actually a preset material for soap. Somewhere here, soap bubble, with your incident and your material refractive indexes are both set to 1, and then only the thin film is the refractive index of soap. And you can actually play with this to see how this changes. So you can change the thickness of the thin film, which creates different patterns, and then you can change the refractive index of the soap itself, which is a lot of fun. And then thin film, the film attenuation rather. Basically, as a film gets thicker, some of that light gets scattered around, and impurities in the material means that it loses energy as it goes through. So if you set this to 1 and you make the film thicker and thicker, you'll see that pattern actually starts to slowly fade until it's completely gone. So that's what the film attenuation is for. Here's another nice example, which I said is to bismuth. And if you look at the bismuth image, you'll see something like this. If you type in bismuth statue, you'll find images like this. This is basically a variable thickness of oxidized bismuth on the outside of a bismuth statue. Someone has gone in and with a blowtorch created a thicker oxidized layer on the bottom, and then gradually as you go up, that layer becomes thinner and thinner, creating different colors. We can actually simulate this in the tool. So I'm going to set this to bismuth. I should do that in the correct panel, bismuth. And then here I have a thickness pass, which is just a gradient. So then I can set that in the thickness map here. And then set this to a more reasonable value. And you'll see that it creates that same color gradient as the real bismuth statue here. Here's another example the tool might be useful for. Say you have a CG render of a character where your eyes look a little bit dull. You can create optical reflection to create a little specular pass to get some pings in the eyes. Of course, it reflects everything, but we're just interested in the eyes. So with a cryptomatte, I'm just isolating those eyes. And then in this case, I have this pass here to create some shadowing. So I'm just keying that out there, and then just plussing over that reflection to create some life in the image. That's actually why I use this tool for most in production, probably. So that, in a nutshell, is optical flares. I hope you find it useful.